All right, so this is supposed to be good. So we do some trigs today. Um, well, not this one. Let me go again and try. Don't know, I get too much fight today. Anyway, all right, so ready again. So listen, you can see this, right? You can see the trigs come up.
Yes, sir.
All right, great. So we can start now, finally. All right, so we're going to do some Pythagoras and then sine, cosine, tangent. So let us start. So Pythagoras theorem, and basically it gives a relationship between the lengths of the sides of a right angle triangle. So you would have been familiar with, this formula, a squared equals b squared plus c squared. And basically this is a relationship between the length of the sides of the triangle, and in this case, a right angle triangle, right? Where you have this longer side is called the hypotenuse, and then you have B and C, right? So usually when you have tricks questions, they would have you, um, there would be like an angle here and here. And of course, this is the right angle. This little square symbolizes the right angle. And, they would say, okay, C is opposite to this angle right here, and B is opposite to this angle. And they would refer to the side that is opposite to the angle. So for example, C being opposite to the angle here, they would refer to C as the opposite. And of course, if you're using this angle as a reference, they would refer to B as the adjacent. Similarly, when you look over this side, B is opposite to this angle here, and C is adjacent to this angle. So we'll see more on that. All right, so we're not going to look at all of that proof right there. We'll come to an example. So it's a find the length of the hypotenuse of the triangle shown in the diagram. And before we look, I will say, okay, the hypotenuse is the longest side in the right angle triangle. And so all they're asking us to do is to apply the trig formula. And we would have seen it up top that says a square equal b square plus c square. So all we have to do is just substitute for the known sides and then find the unknown. And with that, we should be able to easily solve for the unknown, right? So when I look at it now, hold a moment. Yeah, so when I look at it, give me a second. So with a substitute, as I said before, and we have, so substitute for B, substitute for C, boom, boom, boom. And then right here, we'll just take the square root of A, because we have A squared equal 52. To find A, we take the square root. And that's it, 7.2 centimeter. Always keep in mind the unit of measurement as it relates to the length. So the lengths were in meters, well, centimeters. So you have 6 centimeter, 4 centimeters, and your answer, should be in centimeters, unless otherwise specified. And of course, as I give you an answer to 2 decimal places, go down here. I don't know why they changed it to 1 decimal place, but I guess if we know what the square root of this is, I don't know, but it should have 2 decimal places, because that's what the question asked. So that's weird, but anyway, right here, so find the length of the side of the triangle marked X in the diagram. So before we were asked to find the hypotenuse, but now they're asking us to find this length x. So it's the same formula that you would apply. You just need to make sure that in the one before, you recognize the positioning of what's going on. So A, in this case, would be the hypotenuse. So basically the squares, the sum of the squares of the two shorter sides should equal the square of the longest side, right? But in this question now, they're asking for the length of one of the shorter sides. So all you would have to do is just substitute for the longest side here. You would have, 6 squared. And then this 3 now, this 3 could be B or C, don't really matter, right? This could substitute for C as I did here, or it could substitute for B and name it the other side with the unknown, other shorter side with the unknown. So either way, at the end of the day, it is finding the length of one of the shorter sides. So you have 6 squared, 36 equal x squared plus 9. So you got x, so it's x initially. So what you would do here is to substitute x into one of the unknown, one of the shorter side. So it says right here with b equal x, right? But in the formula, it's b squared. So you have x squared plus 3 squared, and then carry the 9 over. Okay, I want to isolate the x squared to solve for it, and then you get 27, take square root of both sides. X is equal to 5.2. So nothing crazy, everything is fine. And then they ask us now to find the length of the side marked x in each triangle. So is it the same setup? I guess I could work an example. All right, so give me a second. Work an example. So let us see. Let's say it's 4 and 3, and the longest, they're asking us to find the longest side. Now, this is a well-known setup, and the answer is, I believe, 5. So we can even do it mentally. So this would be x squared is equal to 4 squared plus 3 squared. 4, 4, 16 plus 3, 3. You get 25 because 3, 3 is 9. So 16, 9, 25 would be equal to x squared, and then you take the square root of both sides, you get 5. Now, over this side, it might take some more work. So same thing again, I'm finding the longer side. So you would have 5 squared plus 12 squared is equal to x squared, right? So you would say, all right, 5, 5 is 25, 12, 12 is 144, right? You add 25 and 144. What do you get? 169. And then you take the square root of 169 and you get 13. So, these things don't really require, much brain power, but can still work it out, right? In the exam, you have to show working. And then you have some type like these that maybe, when you find one of the shorter side, you may want to, well, of course, you're going to have to show working and everything. But for multiple choice, it would be good if I can practice, just working it out without having to write it on paper and be confident with the answer, right? So for this one that we see in C, you find the shorter side. So I'll actually write this out just to show as an example. So I have 15 on the longest side, 12 on the shorter sides. So if we can switch out. Let me switch out and go here. So I have all right. right? So this is supposed to be a right angle triangle, not the best. Say it was what, 12 here, and I think 15 down here. That wouldn't make sense, right? Because this has to be the longest, the longest side. So it would have to be the other way around. All right, so that'll be 15 here and 12 here. All right. So we're asked to find x. So basically the setup would just be, say, it'll be 15 square, so 12 square plus x square. You're trying to find x. So say, okay, 15 square is what? It's 225. And 12 square is 144. So you want to isolate the x square now. So you subtract, you get 81. And then you take the square root of both sides. So x is equal to 9. Right? I'm not sure if it was in meters or centimeters, but whatever the unit be. So you just put the unit here. Say whether centimeter or meter. All right, let's go back. So it's actually centimeter. All right, so that is an example, and all of them follow that same pattern, right? You just need to remember the formula a squared equal b squared plus c squared. And then for these now, just say find the length of the side by x in each triangle, give your answers correct to 2 decimal places. So this is just the same setup, but they're asking you to the additional piece. Then we have these now that have a little, says like worded problems and kind of show some application. So there's an Andrew runs diagonally across a school field while Rakif runs around the edge. So how far does Rakif run? How far does Andre run? How much further does Rakif run than Andre? So if you read it again, it says Andre runs diagonally across a school field. So from here to here, while Rakif runs around the edge. So Rakif go from here and then him go here. Right, at least based off the diagram, that's the information we get. And so how far does Rakif run? So Rakif, based on how the measurement set up, so to go in this direction, call it vertical, right? From his perspective, he's just running forward, maybe. Yeah, he's just running forward. So it'll be 200 meters, and then to go to in the horizontal direction, 120. So you add both of them, you get 320. So Rakif run a total of 320 meters. Now Andre just cut across the field. So if you look on this, what Andre did was to take the diagonal or take the hypotenuse, some would say. So because the questionnaire said take the diagonal. So take the hypotenuse if we were to look at this as a right angle triangle. So we're tasked with finding this hypotenuse. So let us draw it up and see. So let me see if we can draw it up a little. We use this side. All right. So it looks something like drawing us a hot butt. Let us see. All right. So Andre took the diagonal. And I think we had in the question that this was 200 meters, and then across is 120 meters. So these two would be our shorter sides. So if we remember our formula, a squared equal b squared plus c squared. So we're trying to find a. So in this case, or b, we can choose any one of them to be our b. And then that means the other one would be c, the other shorter side. And then you work this out. So you see some big numbers. Let me see how big they are. Probably not that big. Right? So we have 40,000 there. Oh, where's my mouse? So I have 40K. And now we have 14,400, right? And we add both of them together. We get 54,400, and then we take the square root. So let me actually write it down. And then I take the square root now. So all this is a squared. So a square. Time to take the square root now. We take the square root, we get 2, 4, and this is to 2 dp, right? Because, or so if I were to write it out, it would have been, so let's give it an original number. Put it here, 233.238,075. So this is as many decimal places that my calculator displays, right? So 2 decimal places, I look here, the second decimal place, and you look to the number beside it. Is it greater than or equal to 5? It is. You add 1 here, and you drop everybody here. So you have 233.24, right? Because I know I haven't gone through rounding, but something that you guys should be familiar with, right? All right, so let us continue. So, and then we have other application type questions. We have this talk about this a guy rope is attached to the top of a tent pole at the height of 1.5 meters above the ground and to a tent peg 2 meters from the base of the pole. How long is the guy rope? So the guy rope is on the hypotenuse. So it's diagonal here, and we know that means it's the hypotenuse. So you're basically using 2 meters and 1.5 meters as the 2 shorter sides. And then you go ahead and square them, add them, take the square root, and you find what the length of the guy rope is, right? So I figure you guys get the drift. Here's another interesting one. A rope is fixed between 2 trees that are 10 meters apart. When a child hangs onto the center of the rope, it sags so that the center is 2 meters below the level of the ends. Find the length of the rope. Another interesting one, right? As I can see, you have the length here. If you were to break it up into 2 right angle triangles, then you could say, okay, this is 5 meters here, and another 5 meters here, and you could find a diagonal, which is the hypotenuse here, and whatever you find here would be the same here. So whatever you find here, just multiply it by 2, and that would be the total length of the rope. So yeah, so just to repeat, the 2 shorter sides for one of the triangle. One of the triangles would be 2 and 5. So 2 square plus 5 square. So 2 square, 4, 5 square, 25. Add those 2 together, get 29. Find the square root of 29. It is some number. .385, call it 5.39. and then you multiply that by 2, right? So 10 point, call it 10.77 before rounding. So I just took the number multiplied by 2. So as you can see, it makes sense. The length of this thing is just a little bit more than the length between the two, what do you call it, between the two trees, because these are representing trees, right? And that makes sense. It should be more. It can't have this length being less than the rope length being less than the length between the trees. That would be craziness. Like, how would it be able to sag, right? How would it even be able to, be together? It would be two pieces of rope with some space separated, right? And then we have more examples. So you guys can go through these. We can see what else is here. So you have these type now where, it's a little more interesting, where it's compounding. What I mean is just that you have a right angle triangle fixed on another right angle triangle. Nothing special, right? So once you find the length of, like for example, in this case, y, then that would help you to find the length of x. And that's how it would work. So we can go through this example now. Give me a second. All right, back. So we can go through this right now. We have solution. First, I need to find y, which is the hypotenuse of this triangle down here. So the usual formula, square these, so 4, 4, 16, 4, 4, 16, add them up, get 32. Right, and then, so 32, look what they do, which makes a lot of sense. Some person, what they would do is to find the square root of y, and then they put it here. And then when you are supposed to look at the next triangle now, which is here, they just break it up into two pieces. You would then square it again. Okay, I have the number now, and you would just square it again and say, okay, the square of this plus the square of this, add together, then take the square root to find this. But guess what? You already knew what the square of it was. The square of y. You had y squared already, but you need y squared down here. Y, take the square root if you're going to use the square. So you just keep the square instead of the square root. Either way, you wouldn't get it wrong. It's just that you would save yourself one step. Right? There are probably two. Because you would have take the square root and then you would have try to square it again. So I don't know. So you would save yourself a step or two. So for this next triangle, there's x squared equal y squared plus 2 squared. So you have y squared already, which is 32. Substitute 32 centimeters. And for, when you're working in general, you don't have to put the units during the workout. You can just put it at the end. Sometimes it's clumsy to be working with it all the way through. Because look at even this, you have to put 4 cm squared, that's same. Just put 4 square, 4 square. At the end of the day, you put on the unit of measurement. So, and they put the note here. So when finding the side x, it is not necessary to find the square root of 32, but to simply use y squared equal 32 centimeters. So that made the point down here. Cool. All right. So another one is find the value of x, right? Let's find the value of x. You have 13 is the hypotenuse, and the two shorter sides are 2x and 3x. So just as before, when I use a formula, the longer side square is equal to the square, well, is equal to the sum of the square of the shorter sides, right? So you go and you work it out, boom, boom. So 2x squared plus 3x squared, you get 4x squared plus 9x squared. And you come down here until eventually you're able to isolate the x squared, and then you take the square root and you get 3.61 to 2 decimal places. So it's really that's would be be something different in the question where you have not just x by itself and I'm say, okay, find x, find the length of the side x, but they may have a situation where they say, okay, find the length of the side 4x and 3x, whatever you want to do. So even check this out. This is a very interesting question. Very interesting question. Let me see if I would probably do this one, right? Why is this interesting? Because is unlike the other questions where you feel like it's easily, you can easily break it apart. So for example, this one, you have 6 and 8, and it's all right, let me just find the hypotenuse. Here, you find the hypotenuse, and then you use that information to find the shorter side of the other triangle. In this question, F, you have to look at the inside and outside triangle. Say the outside triangle is this one, where the total length at the base here is 5, hypotenuse is 15, and what you want to do is to find the height, because this inside triangle here and the outside triangle share the same height. So once you can find the height of the outside triangle based on the information, 15 being the hypotenuse and 5 being the length of the shorter side down here, you find this, the height, and then now you use the height and the length of the shorter side, because they're looking now at the inside triangle, and then you find the hypotenuse. Take the square root and you get x. And that's how you would do that question. I don't know, maybe we can look at it. Let us see. So it is 15 here, 2 and 3. 15, 2 and 3. Let me see. All right, that will not draw so good. Let me do a smaller one. All right. And then here, I think 2, 3, 15. That's a right angle triangle. And x is right here. So for the outer triangle, so remember the aim is, we're trying to find the height first. So the height for the outside triangle would be the shorter, one of the shorter sides. So if I were to highlight just the outer triangle, it's going to be a little difficult, but bear with me. All right. Use this pen. Then it would be 15 square is equal to 5 square plus sum. So let us refer to this. Can I refer to it as h? So h squared. So 15 square minus 5 square is equal to h squared. Now we can put this in a calculator Of course, it could actually work this mentally, you know. You could use the difference of two squares and work it mentally, but I'm not going to go there, right? We probably do just for this, just for the fun of it. So you have 15 square is that, and they have 5 squares, 25, so you get 200. So at the end of the day, you get 200. So you get 200 is equal to 8 square. So this is 200. Take the square root of both sides. Right? Now, should I take the square root of both sides? Maybe not, right? Because maybe I can just work with 8 square. So let me not take the square root and work with 8 square. So 8 square is equal to 200. Now, what we want to do is to find x. Now, x is, or the relationship is x squared is equal to 2 squared, because now we focus on the smaller triangle on the inside. So it's 2 squared plus 8 squared. And we know that 8 squared is 200. So this is 4 plus 200. So this is 204. Take the square root to get 14.28. So x is equal to, I will take the square root to 14.28. So whatever the unit want to be, I'm not sure the unit, right? I don't know if it's meter or centimeter. All right, let us go back. Okay, so they didn't have any unit on it. So if we go down now, we see some other questions where, you know, they have like a x involved, say have 8, 4x and x on the shorter sides. So we can do a question like that. For the sake of completeness, so 8 on the longer side or the longest side, and 4x and x on the two shorter sides. Let me switch back. Try and get some space, I know. All right, so I'm trying to find this thing. So I have all right. So I have 8 and then 4x and x. So we know that the formula is like this. So we have 8 squared is equal to 4x and square it and x squared. So this is 16x squared, x squared, and 8 is 64. So what you have is 64 is equal to 17x squared. Now we're going to isolate and see, so x squared is equal to 64 divided by 17. Hopefully that is a nice and clean division. Well, not. It's not nice and clean. It is. It is. I'm a calculator messing around. Okay. So I have 3.76. Let us put some more on it. So when I take the square root, it's nice and lovely. So x, I take the square. So this is a square. This is, we're still at x squared. So we're going to take the square root. I'm going to take the square root now. We get 1.9. So I'm just clean this up right here. So we get 1.9. What's that, man? It's itching. All right. So we get 1.9. And if you want, so it'll be 1.9 to be, let me carry it to 2 decimal places, right? So it's 1.94. And of course, we can always check. We can always check and see. So let us just do a check to see if when we use 1.9, it work out. So if x was 1.9 here, so let's check it out. So if it had, so x is 1.94. So of course, we'll leave a rounding happens. So not going to come back exactly to 8, right? 1.94. And so 4 times x, so 4 times 1.94. So let me call the other side y equal 4x, which is 7.76. So if we take the square of these things, it should come close to 64, right? So let's check it out. So 1.94 square, let me do that. 7.76 squared. So I'm gonna square this. When I square this, I get 60 point. And when I square 1.94, I get 3. So this is just me checking it out. Like you don't have to do this. I just showing you guys that this thing actually works, right? Okay, so when we add them up, we get 63.9812, right? So we're very close to 64. So because we're trying to compare it to 8 square, which is 64. So we're off by a little, right? Because of the rounding, but it does show that it works, right? All right, so going back now. So that's how you do those kind of questions. And you have some more working out type, worded questions, application that you can try because they do come in the exams. You can try them. Look at this very interesting question here. Okay, it looks interesting. And of course, we can do them together. No problem. I'm gonna have more. Let me see. Another interesting question. A thin steel tow is supported on one side by 2 cables. Find the height of the tow and the length of the longer cable. Right, so you would simply find the height here from the base to this cable, and you can, because you have 25 and 40, so 40 would be the length of the inner cable here. So, and this would be like the one of your shorter sides in a right angle triangle. So you have the information 40 would be hypotenuse, 25 length of the shorter side. Find the unknown here. After which you get that length, then you add 10 to it, and you use this as a length of your shorter side now to find the hypotenuse of the outer, what do you call it, steel cable. In this case, your outer triangle. In other words, your outer triangle. So boom, 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 and you're good to go. All right. So we're here now, we're on trig ratios. So maybe I need to take a break and come back. Let me pause and then come back, right? All right, guys. So we're back. Let me check on something. All right, so we're back in the place. So we're looking at trig ratios, sine, cosine, tangent. So when working in a right angle triangle, the longest side is known as the hypotenuse. The other two sides are known as the opposite and adjacent. The adjacent is the side next to a marked angle, and the opposite side is opposite this angle. So look here, opposite is opposite to the marked angle, and adjacent, this side is adjacent to the marked angle. And of course, the hypotenuse is the longest side. For a right angle triangle, the sine, cosine, and tangent of the angle theta are defined as sine theta opposite over hypotenuse. Theta opposite over hypotenuse is referred to as sine theta. Cos theta can be written as adjacent over the hypotenuse, and tan theta is just the opposite side over the adjacent side. So it's a sine theta would also have the same value for any particular angle, regardless of the size of the triangle. The same is true for cos theta and tan theta. All right, so if we go down, so work example, it says for the triangle and angle shown, state which side is the hypotenuse. So we know hypotenuse is just the longest side. So C to B, that's the hypotenuse. The adjacent, so this is the marked angle, the adjacent runs right along. So from A to B, that's the adjacent, and then the opposite side is just opposite to the angle. In this case, length AC would be your opposite side. Now, for example 2, it says write down the values of sine theta and cos theta and tan theta for the triangle shown. Then use a calculator to find the angle in each. So I have 6, 8, 10, and they ask us to find sine theta. So sine theta is up here, it says sine theta is the opposite over the hypotenuse. I'm sure you guys will probably hear SOHCAHTOA, so that helps us to remember the trig ratios, right? What side over what side gives sine, what side over what side gives cos, what side over what side gives tan. And I can quickly show you so you can use it to remember in the exam. So ka toa. So this is saying the sine theta, sine, all right, I'll come better. The sine theta is equal to the opposite side over the hypotenuse. And then the cosine theta is equal to the adjacent side over the hypotenuse. And then the tangent, tan theta, is equal to the opposite side over the adjacent side. So that's something I can use to remember the trig ratios. I think they call refer to these things as mnemonic. Right? That's an easy way to remember certain things, right? So with this example, they ask us to find sine theta, cos theta, tan theta. And just like that, so sine is over hypotenuse. So we looked through this already. Nothing new here. So here they're giving some relationships about in the triangle. In the triangle opposite, we know that. And they use it to prove the Pythagoras Theorem, which is interesting to show that relationship that sine theta b over a, cos theta c over a, and then when you take the square of them, it worked together to give you b squared plus c squared over a squared, right? And then, so this is just some proof of the identity. You don't need to know that for exam, but it's good to look at. So you have this is equal to this, and it's a by Pythagoras theorem. We also know that a squared equal to b squared plus c squared, right? So a squared being the hypotenuse. So they just equate them, and before you know it, you get this thing, right? So yeah. Let me say the result, let me give you this result is a useful result. For example, and theta is equal to 45 degrees. It says sine theta equal cos theta as two sides, C and B are equal. And they give just some things that these things I don't need to know. Okay. Yeah, as in the proof, just good, it's good to understand, but you can you can answer questions without knowing the proof. All right, so it's a for each triangle, state which side is the hypotenuse, the adjacent and the opposite. So again, you have the marked angle here. The side that is opposite is the opposite. The longest side is the hypotenuse. The side that runs along the side of the marked angle is the adjacent. Similarly here, this is the opposite. It is opposite to the angle. This side here, D to E, is the adjacent. It runs across. And of course, the longest side is the hypotenuse. And it goes on and on and on. The longest side is here. That's the hypotenuse. HI is the opposite. It is opposite to the angle. GH is the adjacent. And you just keep, doing that over and over. So write sine theta, cos theta, tan theta as fractions. Remember SOHCAHTOA. The sine of this is opposite over hypotenuse. So 3 over 5. The cosine, ka, adjacent over hypotenuse, so it'd be 4 over 5 would be the cosine, and then tan tau, which represent the tan of the angle, is just the opposite, in this case 3 over the adjacent 4. So just like that, we were able to determine the trig ratios, right? And then let's say use a calculator to find these. So just use a calculator, put in sine 30. I just put it in the calculator and you can confirm that you think right. And so use a calculator to find theta. In each case, you get answers to 1 decimal place. So you're going to have to use the trig inverse on a calculator now. So whether it was sine inverse, give me a second. Sine inverse, cos inverse, tan inverse, right? So just look on a calculator, you'll see the inverse on it. Or if you're not so sure about your calculator specifically, you can go on. Just look up the model and go on Google or YouTube and see if you can find the inverse on a calculator. Right? All right, so going down, it says find the, say for the triangle shown, write down expressions for blah, blah, blah. So we know this. So this time I have 2 angles, well, that the mark 1 alpha, the mark 1 theta, and there's a cos theta again. Cos, you use, the whole SOHCAHTOA thing, it would be ca, which is cosine theta is equal to adjacent over hypotenuse. So if you're referring to theta, so this is theta now. So ca adjacent, so the adjacent to theta would be z, and then x is the hypotenuse. So z over x would be the expression for cos theta. For if you were looking at cos alpha now, the adjacent for alpha is y. So ca adjacent over hypotenuse, it would be y over x. Right? Tan alpha. So remember that tan tau. So just remember tau opposite over adjacent, and you're good to go. So here's the findings in right angle triangles. When one angle and the length of one side are known, it is possible to find the lengths of other sides in the same triangle by using the sine, cosine, or tangent formula. So for example, sine 50 degrees is equal to x over 12, and then you solve for x, which is 12 sine 50 degrees. So here, we're basically using the trig ratios and the relationship. So remember, we would normally like theta here or alpha, but now we see an actual number. So sine something is opposite over hypotenuse. So sine 50 is, the opposite is x, the hypotenuse is 12, and you solve for x. When you come here, again, in this case, let's see, so you have this here, trying to solve for this. Of course, I have to use a trig ratio that includes the side that you're trying to find and the side of the known. So check this out. This is opposite. This is hypotenuse. Then, it's sine. Sine gives you, sine relates the opposite, the hypotenuse, to the angle. You couldn't use cosine. Cosine, you would need the adjacent. You don't get no information about the adjacent. Well, to be fair, a man may say, wait, sir, I can use cosine. I can find here the adjacent. I can relate I can relate the hypotenuse to the adjacent with the angle, find this here, and then use Pythagoras theorem, and this would be one of my shorter side. This is my hypotenuse, and then find x. So fine, I can do that. Or I can even use cosine, find here, and then use tangent and find here, because now you would have the adjacent and the opposite. And for tangent, that's all I need. It says tau, opposite, and adjacent, and you have the angle, and you can relate them. But to save time, the first trig ratio you should use is the one that relate all the information together that is presented in the question. So in this case, the hypotenuse and the opposite with the angle can come together with a sine trig ratio, right? And that's what I do here. So opposite is x, sine 30, and then the hypotenuse is 20. I'm saying sine 30, I mean sine 70. So sine 70 is equal to the opposite over hypotenuse, and then solve for x by multiplying both sides by 20. And you're good. So find the length again. So check this out. Opposite and adjacent, we have the angle. What relates to opposite and the adjacent? Tangent, right? So tan theta is equal to the opposite over the adjacent. So tan 40 opposite to adjacent is solve for x, multiply both sides by 8. And it goes on. So in this case, now the adjacent is unknown, but you know what the opposite is. So again, tan, this time, you know, it's in the denominator. Well, fine. You just make x a subject of the formula. Multiply both sides by x, divide both sides by tan 42. And before you know it, you get it. Another example. Examples keep coming and coming, right? So you have the hypotenuse and you have the opposite. So again, this is a sine. Not that it is a sine, but this is a sine trig ratio that relates the opposite and the hypotenuse. Again, this time that the unknown is in the denominator, you just make it the subject of the formula, multiply both sides by x, divided by sine 28, and then you're good to go. Here's a question. What does it say? The diagram above, not drawn to scale, represents one face of the roof of a house in the shape of a parallelogram. EFGH angle EFI equal 40 degrees. So EFI, this angle, they say angle EFI. So usually F would be the point of the angle, so the middle letter. Sometimes they put like a hat. Some people refer to it as over the middle to just make a point that that's where the angle is, or that this is an angle. And then you have 40 degrees, and then EF, which is the length, right here with the hypotenuse. And then you have EI represents a rafter placed. There's a EI represents a rafter placed perpendicular. So EI placed perpendicular to FG. No problem, such that IG is 5. So this is just describing all what's going on up here. So calculate, give your answer 3 significant figures, the length FI. So FI. So again, so in this triangle here, you have your hypotenuse, you have to find the adjacent, you have this here, relate the adjacent and the hypotenuse, that's cosine, adjacent to hypotenuse. Right, so just remember, when I say these things like SOHCAHTOA, all I'm doing is referring back to this here, SOHCAHTOA. So start off with S, the S is a sine, and then you have opposite over hypotenuse. So whatever comes second is in the numerator, goes in the numerator, whatever comes third goes in the denominator, and the first one just is the first letter of the trig ratio, or the trig function. Would have the sine, S for sine, C for cosine, and T for tangent. So when you hear me say so, that's what I mean. So opposite over hypotenuse. So sine theta equal opposite over hypotenuse ka. Cosine theta equal adjacent over hypotenuse tau. Tan theta equal opposite over adjacent. So going back. So Fi is relating, so this relates to cosine together. So ka adjacent over hypotenuse. The adjacent is the unknown. So the 8 would be in the denominator, so I multiply both sides by 8 would be 8 cosine 40. Just as I have here. Then it asks for EA, no, my bad, EI. So you're relating the opposite to the hypotenuse, you can use sine, right? And that's where you get 8 sine 40. And then so the area of EFGH, so what they do here is 5 plus 6.13. So the 5 that is here, and then a 6.13 for Fi. That would give you this length here, FG. And then EI would be here. And that's where you find the area of a parallelogram. So the length of one side times the height. Now you have some exercise now. So you can try these. Let's pause the video. Try them out. Right. What I'll do is to send you guys the solutions to them. You know, I don't think, yeah, the way the solution set up, but they don't have any workings, they just have the final answer, so I can send those. No issue sending those. So it's more or less the same if I choose one at random. All right, this one, middle one at random. What is asking? Find x. X is, x is opposite to 45. 26 is the hypotenuse. Relate opposite and hypotenuse. So sine theta equal opposite over hypotenuse. Opposite is x. Hypotenuse is 26. And so all I have to do now is, all right, finding x, multiply both sides by 26, because 26 will be in denominator. So you have about 26 sine 45. I can choose anyone at random, and same concept will just apply. All right, check this out. So this look cool, something against the wall, same concept. How far is the top of the ladder from the ground? So this is the ladder, I believe. Like this is the wall, because it's a ladder leans against a wall. So this is the wall. This is a ladder that is leaning against the wall, even though it does look like a line, right? So I guess that's what it would look from a distance. Yeah. So yeah, the opposite, not the opposite, my bad, the hypotenuse, and asking you to find the opposite. From here to here would be the opposite. Ask yourself what relates to hypotenuse and the opposite, you think. So Kato, you go through opposite and hypotenuse. All right, so sine, opposite, and the hypotenuse. So sine, the unknown, so sine theta equal unknown, you can call it x, divided by 4, and then you're trying to find x. So which side would take by 4? So you get 4 times sine 58. So how far is the bottom of the ladder from the wall? So here is the bottom of the ladder, and here's the bottom of the wall. So you can just relate the adjacent now to the hypotenuse, which you can use cosine adjacent over hypotenuse, in this case, adjacent. So adjacent unknown says x equal 4 times cosine 68. And good. Here are some more interesting questions. I like these. We can work them out at another time. Well, you work them out, pause the video, work them out. We discuss them in the next class. Very interesting stuff, very interesting. Ship sails 400 kilometer on a bearing of 75 degrees. How far east as the ship sail, or far north as the ship sail? Some interesting questions. Same concept. Find the length of a side of my x in each triangle. So there are quite a few questions. So this one now, finding angles in right angle triangle. So in this case, I have to use the trig inverse, right? Which is just a way of finding what angle is in the triangle, is in the right angle triangle, finding the actual number for the angle. So in this question, I have 1810. I want to find what this angle is. All right. Okay, so the worked example actually is here, 14 and 20. So here's the marked angle. So you're trying to find the angle. So before we were trying to find lengths, we passed that. Now we're finding what the angle is. So I have 14 and 20. So we're trying to relate the opposite and the hypotenuse, which is sine. So we know that sine theta, see here, sine theta is equal to 14 over 20. So the one unknown I have is theta. So 14 over 20 is 0.7. So to get what theta is, we have to apply the sine inverse. When a sine inverse here, theta pops out. So it's like the inverse removes a sine from here. So you just get theta. And then the inverse, sine inverse, now you have sine inverse 0.7. Plug that into your calculator, you get 44.4 degrees. So 44.4 degrees. And again, here's another question. You have the opposite, you have the adjacent. You relate the opposite to adjacent, that is what? Tangent. So opposite 25 over 4, you get 6.25. Take tan inverse of both sides, you pop out the theta, and this is equal to tan inverse. Put that in a calculator, you get 80.9. And you should not convert, but confirm these numbers in the calculator so that you know that you're using the calculator properly. So see here, it says shift tan, so that sometimes for some calculators, that's why you access the inverse functions. For others, it's probably simpler, right? Sometimes you will see like the inverse just above the tan function. So you probably see tan on the button and then tan inverse right above. So just see how your calculator set up and use it accordingly. Here's another question. So in this question, they're asking you to find the length of QS, which is here to here, and they're asking you to find the size of the angle X, which is here. And again, you apply your trig ratios, right? So you get QS is that, and the length of the size of the angle X. So if you have QS, and this is the opposite, so 9 is opposite to X degrees, and then QS is adjacent, opposite over adjacent tau, so that is tan. So therefore tan, so you have to find what that is in the opposite over the adjacent. So 9 over 10, right? 9 over 10, that's 0.9. So you're finding now tan inverse of 0.9. So theta is equal to tan inverse. I said that, right? So theta is equal to tan inverse of 0.9. And you get a number, and that number is 42 degrees. I continue that way. go through, you do the other questions like that. If I were to at random again, so you're relating hypotenuse to the opposite. So basically sine, so what you have is sine theta is equal to 8/10, which is equal to 0.8. So once you reach here, so you reach sine theta is equal to 0.8. Now you need to find out what theta is. So you take the inverse of sine. So sine inverse on the left side will give you a theta, and then on the right hand side, we have sine inverse of 0.8, which I put it in a calculator. Like my calculator, I don't know where my original calculator is, but yeah, so you take sine inverse of 0.8 and you see what happens. Right, you get your answer. Moving right along until I can find a calculator, right, that can give me my answers. Another question can do another one at random. So something slightly different. Let me see. All right, so if I choose something slightly different, there's not so much at random then, because now I'm looking with intention. So I have opposite and adjacent. See there, opposite, adjacent, or 15/14 give me a number. So 15 divided by 14. I get 1.07, right? And then I'm going to take the tan inverse of that, right? Let me see if I can find it. So let me see if I can. Right, the inverse not coming on this here. So I'm going to have to find another calculator that can help. But you guys get the gist of the thing. I may have more questions, more of the same, more of the same, more of the same. So do try these questions, okay? As I can see, it's at 6C. They can do this one here, and then you can do this one, and we can talk about it next class. This one. So these questions are almost, so from, let me see, even 8 too. 8, 9, 10, 11. So those questions, right? So pause the video at each one and go through. So 8, can pause here now, do the question, then we'll go again. 9, can pause here, do the question, and 10, pause the question, and 11, pause the question. So the next class, more likely I will kickstart by working those questions. Right, so that's what I'll definitely do. All right, in the little time that I have left, let me see if I can look at the other paper real quick. Let me see what is there. Let me see what is here real quick. Oh. So it's a mixed problems. Okay. So this looks like some angle of elevation and depression. So real quick, so basically everything that you so far are going to be important, right? They're going to carry over in the other trig topics. So let me just talk about this real quick. So it says, when you look up at something such as an airplane, the angle between your line of sight and the horizontal line is called the angle of elevation. So if you look up at the airplane, so this is a line of sight looking up. So it's the angle between your line of sight here and the horizontal. The horizontal goes right across. And this second angle right here is the angle of elevation. And so similarly, if you look down at something, then the angle between your line of sight and the horizontal is called angle of depression. So this is the horizontal, the line of sight looking down at something, this angle of depression. So if you look, give some, an example. A man looks to the sea from a cliff at about 12 meters. He sees a boat that is 150 meters from the cliff. What is the angle of depression? So the man looks out to the sea from a cliff. So the cliff is at the top here and he's looking out, right? And the height of the cliff is 12 meters. He sees a boat that is 150 meters from the cliff. So the cliff here, 150 meters, the boat is up here. What is the angle of depression? So he's at the top of the cliff looking down. So angle of depression, if you remember the definition, it says it is the angle between the line of sight and the horizontal, right? So the line of sight here is the man looking down, and the horizontal, of course, just goes right across. So the angle that is formed is the angle of depression. Now, you can think of this horizontal, well, nothing. It is 150, and this 150 you can nothing, but this 150 is really, as it relates to this marked angle, is your adjacent, and then 12 meter, if you measure from here to here, is your opposite. So relating adjacent and opposite, and of course that is tan, opposite of adjacent, right? Now, some people use like the Z angle thing as, okay, if I can find here, just find this angle, then this whole Z angle thing, then this angle and this angle is the same thing. So either way you can think about it, but you use a tan tower opposite over adjacent, 12 over 150, and right, because of course, even though it says 12, so even though it's 12 here, as of course from here to here is 12. And then 150 from here to here is 152, because this is if you complete this line here, you get a rectangle, right? And the inner angles, are 90 degree, 90 degree, 90 degree, right? So that's why I can say this 12 can be represented here as well. And of course, this 150 can be up here as well, right? And then you can look at this as the opposite, and whatever this 150 is up here as the adjacent. All right, another example. A person walking on an open line can see the top of a radiant mass. The person is 200 meters from the mass. The angle of elevation of the top, the mass is 3 degrees. What is the height of the mass? So somebody walk on an open land is here in the open land. The top of the radiant mass is somewhere way up here, and the person is looking out. So this is the line of sight. They're looking out, and they see the top of the mass, and horizontal is horizontal, right? So you have 200 meters from where the guy is looking. Well, it's a person. So where the guy or girl is looking, you're here to here. So from where they're looking to the actual radiant mass is 200 meters, and then we are asked, and they tell you the angle of elevation, and you're asked to find the height. So you relate the height to the adjacent, another time again, and you solve for the length. So this time you're solving for the length. So that's why it mixed. Of course, another solid question. This is a must do. It says CXC, must do it. And of course, they have the solutions. So if you read through, a ladder is 3.5 meters long. It is placed against a vertical wall. So this is the ladder against a vertical wall. So that its foot is on the horizontal ground. It makes a 48 degree with the ground. So this is the ground, this is the ladder, and 48 degrees with the ground. Then it says what? Draw a diagram which represents the information given. Label the diagram showing the ladder the wall, and the ground, and insert all measurements given. So here, that's the diagram. Calculate to two significant figures the height the ladder reaches up the wall. So that's on side opposite. So from here to here would be the opposite to the angle. And if you just look at it, so this is 3.5, which is the hypotenuse. This is an angle you're trying to relate that the hypotenuse, the angle, and the opposite. Again, that sounds like sine. So opposite over hypotenuse, and the S again stands for sine. So sine theta equal the unknown, you can say x over 3.5, and then you solve for x. So x is in the numerator, 3.5 is in the denominator, so it is 3.5 sine 48. Put that in a calculator, and you're good to go. And then they say the distance, the foot of the ladder is from the wall from here to here. Again, you can relate this 3.5, the angle, and the adjacent. So that's what adjacent over hypotenuse. So cosine theta is equal to the adjacent, which is the unknown, over the hypotenuse of 3.5. 3.5 is in the denominator, trying to solve for x. So it's just 3.5 cosine 48. Put that in a calculator, you're good. So you can say down here. And then the last question is calculate the angle that the ladder now makes. Oh, it says the top of the ladder is lowered so that it reaches 1.7 meter of the wall, still touching the wall. Calculate the angle that the ladder now makes to the horizontal. So they're saying basically the lower the ladder, so they kind of just drop it down a little, right? So it's the same 3.5 because the length of the ladder not going to change, right? So then it's a calculate the angle that the ladder now makes with the horizontal. So now that you drop it to, say, the top of the ladder is lowered so that it reaches 1.7 meter of the wall. So 1.7 is a new height here. The opposite, so it's 3.5 and 1.75 that you're working with in order to find the angle here, right? So that sounds like relating the opposite, the hypotenuse, and angle, that's sine again. So sine theta is equal to opposite over hypotenuse. So the opposite this time is 1.75 over the hypotenuse at 3.5. So sine, let me say that again, sine theta is equal to 1.75 over 3.5. Take the sine inverse of both sides. The sine inverse, so that you get theta is equal to sine inverse. So theta is equal to sine inverse of 1.75 over 3.5. For whatever that is, put in a calculator. So see here, so sine theta is equal to 1.75 over 3.5. You take the inverse of both sides so that you have theta is equal to sine inverse of this. You put it in a calculator, or should I say sine inverse of 0.5. You put that in a calculator, you get 30 degrees. And you have some more questions here, which you can attempt some more angle of elevation and angle of depression questions. Go down, more questions. You can pause the video and attempt some, because you know these are questions that will become on the exam. Like, there's no doubt about it. No doubt. So yeah. And then we reach here. So here now we will leave for another class, right? So that is it for class today. We'll meet again. All right, so all the best. We'll meet again next week. Well, at least Monday. Take care now. Bye-bye.